All right, here we go. Our objective for today. I will identify the greatest common factor and least common multiple of monomials. I will, or I wrote over there, I can identify the greatest common factor and least common multiple of monomials. Let's read together. 1, 2, 3. I will identify the greatest common factor and least common multiple of monomials. Now, this is a lesson we're revisiting from your pre-algebra class. Okay? However, you were introduced to some of these in elementary back in, I think, 5th grade, and some of them in 4th grade. However, today I'm going to show you a different process to do both at once. So I need you guys to be really focused, please. And there is some prayer models, that's why I included them in there, so just fill out the information, please. There we go. So our concepts that we're going to be looking at, bless you, are greatest common factor and least common multiple. Greatest common factor, least common multiple. So here we go. So, first of all, just a quick info so that we can get started with the list. You don't have to copy this, just pay attention. It says, what do I have in common with Michael Jordan? Let's see. I'm going to get a Venn diagram. There's Michael Jordan. There's me. Okay, it's a rhetorical. I'm trying to guide this, okay? Here we go. So Michael Jordan, let's see. Michael Jordan is tall. I'm not that tall, okay? Michael Jordan is a professional basketball player. I am a teacher, okay? Michael Jordan is rich. I'm not rich. But the one thing that actually got me to follow Michael Jordan in his career was the fact that he loved math. His favorite subject is mathematics. So out of all the things, what is the greatest common thing that we have? That we both have our favorite subject is math. Well, guess what? We're going to use this process to do the same but with numbers. We're going to look at different numbers, and then from there we're going to identify which things those numbers have in common. Okay? So here we go. Concept development. On your Freyer model, first of all, I want to clarify factors. What are factors? You already have this in there, and it says 2 or more numbers that are multiplying. 2 or more numbers that are multiplying. Let me give you examples. Write these down, please. 2 times 5 are factors because they're doing what? Multiplying. 2 times 3 times 7 are factors because they are multiplying. How about 3, 5, and 11? Yes, they're factors because they're doing what? Multiplying. 2, 2, 3, 3, and 5 are factors because they are multiplying. Fairly simple. Non-examples, let's see. 2 and 5 right here, they're not factors because they're not multiplying. 2, 3, and 7 on this example are not factors because they are adding. 3, 5, and minus 11 are not factors because they're doing other operations other than multiplying. Look at this. 2, 2, 3, 3, and 5 in this example are not factors because they're doing addition, subtraction, and division. The only time we're going to call them factors is when they're doing what? Multiplying. So things to remember. Make sure you write in your critical attributes, there's 2 or more, and they are doing what? Multiplying. So write that down, please. 2 or more numbers, and they are multiplying. That's what factors are. All right, let's go to the next one. Check this out. Everybody look up. So let me give you a quick, it says, what is a factor in your own words? Think about it. Okay, share it with your neighbor, please. What is a factor? Okay. All right, good. Look at this. Look at number 2. It says, which of the following is an example of a factor? Think about it. We have example A, example B. Okay, everybody got it? Let me get somebody to help me out with this one. How about Marissa? Marissa says what? A, and that is correct. It's A. 2 times 7 is 14, and they're multiplying, so they're factors. Now let's go to the next one. I want to clarify what multiples are. Multiple. Multiple. Everybody look up, please. It says the product of any amount times an integer. Integer. On your Cornell note, it says whole number. I want you to write comma integer. Integer. Okay. Now let me show you some examples. Here it goes. Everybody look up. 6 is a multiple of 2 because it says here the product of any amount times an integer. So let's see. Are they multiplying here? Yes. So the answer of a multiplication and all that is a what? A product. So let's see. The 6 is a product of 2 and 3. So 6 is a multiple of 2, and 6 is a multiple of 3. Is A product of 2 times 4? Yes. Is 8 a multiple of 2? Yes. Is it a multiple of 4? Yes. Is 10 a product of 2 and 5? Yes. Is it a multiple of both? Yes. Same thing with this one. Are we there? Non-examples. Copy this, please. Look at 5. 5 is not a multiple because we don't get it from what? It's not a product. What is the solution to an addition? It's called a sum. So therefore, the definition says the product. Since 5 is not the product, therefore this is not a multiple. Look at this one. And look at this one. Also good? All right, things to remember about multiples is that is a product and it involves multiplication. Here, it didn't involve multiplication. Product means the solution to a multiplication. Okay. So far, so good? All right. So before we get into the next, the example here, let me show you what greatest common factor is. Greatest common factor. I'm just going to label it GCF. Greatest means the greatest number. Common is what both numbers have in common. And factor, that means that it's one of the numbers that is multiplying. We know what a factor is, right? Two or more numbers that multiply. Common is that what is that number that both of them have in common, but it has to be the greatest one. So check this out. If I was to give you the numbers, everybody look up. If I was to give you the numbers 6 and 18. So check this out. 6, the factors of 6 are 2 times 3. Is that correct? The factors of 18 are, let's see, 2 divides into 18. What others? 9. How about 3? Yes. How about 6? And how about 9? Okay. So if I was to multiply 2 times 3 times what else gives me 18? 2 times 3 times 3. Is that correct? How about, let's see, 3 times 6? So from these, which is my greatest common factor for both? What is 2 times 3? 6. Does this one have a 6? So my greatest common factor is 6. This is a way that you were introduced to GCF before. Like I said, today I'm going to show you a different method, okay? So here we go. I mean, we'll move on. I gave you guys some steps. You guys already have them written there in the back. First of all, we need to write the first 5 prime numbers at the top of the page. Second, we find the prime factors of each number by factorizing. Next, we draw Venn diagrams, write the common prime factors in the intersecting area. Multiply the common prime factors to get the GCF, and at the end, multiply all prime factors to identify LCM. And you're saying, oh man, that's a lot of words. Yes, so let me show you how it goes. Here it goes. So they give us the first problem. What is the greatest common factor and least common multiple of 24 and 36? Pens down, eyes up here. Only going to pay attention. the first thing that I want you to do with these, you're going to write the first 5 prime numbers at the top. Why? Because I want to make sure that I have those to start my factor tree. And I already went over this process at the beginning of the year, but here it goes again. From there, I'm going to write my 2 numbers, 24 and 36. I'm going to start with 24. Out of these 5 prime, which prime number divides into 24? 2 and also 3. But I'm going to use 2 right now. So I'm going to write 2. 2 divides in there, and what do we get? 12. Okay. 2 is a prime number. Do you agree with that? Yes, that's why I wrote my first prime. However, 12 is a composite. That means I can factor this one a little bit more. What prime number divides into 12? 2 and once again, I'm going to start with 2. So 2 divides in there, and we get 6 at the end. Are we there? And 2 is a prime number. So far, so good? Now check this one out. 6 can be divided by 2 or 3. So I write it out. 2 and 3. And both of these are what? Prime. So that's why these, if I was to multiply them, at the end I should get the same number I started with, which is 24. That's why these are known as prime factors. Prime factors. Everybody look at 36. Which one of these divides evenly into 36? 2. How about 3? Yes. So I'm going to start with 2. So 2 divides in there, and we get what? 18. 2 is a prime number. There it is. 18. Can I divide by 2 again? Yes, and I get 9. 2 is a prime number. And 9 becomes what? 3 and 3. So, and both of those are prime. And once again, if I was to multiply these, at the end I should get what? 36, because those are the numbers that I start with. Those are known as prime factors. Copy that, please. So far, so good. So we got our factor tree for each one. So let's see. Let me look at my steps. Step 1, I write my first 5 primes. Step 2, I get our factor tree going for each of these numbers. There it is, and I find my prime factors. Are we there so far? Step 3, check this out. Pens down, eyes up here. This is the key part. Pay attention. Now, I'm going to show you step by step how a Venn diagram works. Here it goes. 24, I'm going to write it over here with a circle. And I'm going to write my prime factors. What are my prime factors? 2 times 2 times 2 times 3. There they are. Are we there so far? Okay, those are, of course, because if I do, what is 2 times 2? 4 times 2, 8 times 3, 24. Like I said, if we multiply them, we get the same number. So here we go. I'm going to do the same for 36. I'm going to write the 36 over here. So I'm going to bring that down. My circle, there it is. And what are my prime factors? 2 times 2 times 3 times 3. They go right there. How a Venn diagram works, kind of like I showed you earlier with Michael Jordan and myself, the inner part was what was most common for both things. Is that correct? And in that case, what was the most common thing for Michael Jordan and myself? Math. But did I say math? No, you only have to say how many times? Once, because both of those are the overlapping or the most common thing that we have. So look at this one. I'm going to move these circles so that you can see how this works. This is how they overlap. What numbers do you see are overlapping? 2, 2, and 3. Do we have to say 2, 2, 3, 2, 2, 3? No, we only say it once. And this is a mistake some of you used to make when you got to this point. You wrote it twice, and that's the mistake you made. So now check this out. This part, 36 and 24, the factors that they have in common are what? 2, 2, and 3. When I multiply those, this is known as our greatest common factor. Copy that, please. Okay, so check this out. So I wrote these, check this out, and I know that your circles were not separated and they came together because I already gave you the Venn diagram together. So you're saying, Mr. Q, how are we going to do that here? So this is how you're going to do that. When you get to this part, all you have to do is say, okay, which one of these are the same over here? Let's see. I have 1, 2. Here it is. Okay, 1, 2 right here, and you write it in here. There it is, 2. So we have another 2 that is the same over here. Yes, and then you write it in here. Do we have another 2 over here? No. How about a 3? Yes, and I write it in there. What's left without matching up to over here? The 2 that goes outside over here. What's left over here without matching? The 3. That's how you write it in your Venn diagram. Are we there? All right, now check this out. And this is the part where maybe your elementary teacher did not show you the connection of these two. But here we go. What's that? These common multiple. Yeah, because it's a multiple and it's one of the biggest ones. All right, check this out. So now, once again, to get our GCF, we just multiply the common prime factors that both numbers have, and we multiply them. 2 times 2 times 3, that gives us 12. That's our GCF. To find our least common multiple, we just multiply whatever is left over here times the opposite number. Same here. Now check this out. Everybody look up, please. This is another way of checking for your LCM. Everybody look up to the screen. Okay. This is 12. Is that correct? Okay. What is 12? Let's see. What is 2 times 3? And what is 6 times 12? 72. That's another way of checking it. By multiplying all of these together, it also gives us the least common multiple. We got it? Okay, let's do one together. Copy this next one down, please. Example 2. It says, what is the greatest common factor and least common multiple of 12 and 18? So write those two numbers down, please, 12 and 18. However, what is your very first step that you're going to do with these? Yes. Very good. You write your first 5 prime numbers at the top. So 2, 3, 5, 7, and 11. Write those down. Make sure you are best friends with them. From now on, they are your BFFs. Okay? So you write them up there. Okay? Just don't text them at night, please. So here we go. So you write them down. We're going to write our two numbers, which is 12 and 18. Okay? Let's get our factor tree going. 12. Start with one of these primes. Which one of these divides into 12? 2. So then I start with 2. That's 2 times 6. I circle the 2 because that's the prime number. Which one of those divides into 6? Both of them. So I'll just write 2 times 3 and circle both of them. And both of them are what? Prime numbers. That's why these are known as prime factors. Are we there? Okay, let's do 18. 18 can be divided by which one of these? 2 or 3. I'll start with 2. That's 2 times 9. And that's a prime number. And this is 3 times 3. And we're done. And those are, again, prime factors. Are we there? So, get your Venn diagram. See if you can fill out the Venn diagram by yourself by looking at it. Which ones are the same here, and which ones go in the intersection region. So let's see. By looking at it, I'm going to do this. Here's a 2. Do I have a 2 over here? Yes, I write it in here, 2. They have the same one in common. Do we have a 3? Yes, right here, 3. So I have 2 times 3, okay. Do we have anything else in common? No. So what's left over on this one? 2. What's left over here? 3, okay. So therefore, our GCF, all we have to do is what? Multiply whatever's in here. So my GCF is what? 6. My LCM is what? Let's see. 2 times 18 is what? 36. And to check it, we do 3 times 12. Is 3 times 12 36? Yes. So therefore our GCF is 6 and our LCM is 36. So far so good? Think you got it? Okay, let's do another one. See if you can do this one by yourself. Example number 3. Okay, example 3. What is the greatest common factor in each common multiple of 45 and 36? See if you can do this one by yourself, please. Once again, don't forget to write, your first step is to write your first 5 primes. Okay? All right, let's see what we got. So we got our 45 and 36. 45 could be divided by 5. Is that correct? If you did it by 3, that's fine. But usually any number that ends with a 5, you can divide by 5. So that's why I use the biggest one. So 5, that gives us 9. 5 is a prime, and 9 is what? 3 times 3. If you started with a 3, you still should have gotten at least 3, 3, and 5. Is that correct? Okay. 36 could be divided by 3. This one I started with 3. If you started with 2, that gives you 18, and so on and so forth, right? Well, I'm starting with 3. 3 times 12. This one is also 3 times 4. And this one is 2 times 2. Is that correct? And these are prime factors. Okay? So then we get our Venn diagram going. So therefore, in our intersecting region, what do we get? What is the same here and here? How many 3s? 2. So they should go in here. And what's left? 5. And over here we have what? 2 times 2. Are we there? So what is our GCF? 9. And our LCM is, let's see, what is 5 times 36? 180. Or what is 5 times 30? 150. 5 times 6 is 30. So 150 plus 30, that's 180. And what is 2 times 2? 4. So what is 4 times 45? It should give us 180. So far so good? All right, let's do another one. Example 4. Okay. Example 4. Copy this one down. You don't have to copy all the words. Just copy the monomial. 60x cubed. Copy this, please. 60x cubed and 72x to the 5th. That's why I'm going to show you how to do this one. We're going to work this out together. Focus, please. Here we go. So let's do this one together. I'm going to write 60x cubed, and over here I'm going to write 72x to the 5th. So far so good? All right, let's continue. So, factor tree. My first 5 prime, let's see, which number divides in here? Does it divide by 2? 3? How about 5? Yes, I'm going to start with 5. So 5, and this is 12. I circle the 5. The 12, could it be divided by 2? By 3? Okay, I'm going to go with 3. So that is 4. I circle the 3 because I can't do anything else with it. And the 4 becomes 2 times 2. So, check this out. All of these are broken down into prime factors. I'm going to do the same with this one. How can I write x cubed in factored form? X times x times x. Did everybody see what I did? Okay. Next, I'm going to do the same thing for 72. 72 could be divided by 2, yes. How about by 3? I'm going to start with 2. 2. 2 times 36, and 36 is 2 times 18, and 18 is 3 times 6, yes? And this one is 2 times 3. I just went a little bit different route. And x to the 5th in factor form, how can we write that? X times x times x times x times x. So far so good?
Yes, Mr. Chief.
All right, good. So here we go. So let's get our Venn diagram. Nice and straight like mine. There it is. Thank you. There it is. So focus, please. So this one's going to be for our 60x cubed, and this one for the 72x to the 5th. Yes? All right. So check this out. With red, what factors do we have in common for this one? Let's see. Do we have a 5 over here? No. How about a 3? Yes, right here. So I underline it and I write it in here. 3 times. What else? Do we have a 2? Yes, right here. So I write that in there. Do we have another 2? Yes, right here. Times 2. And do we have anything else on this side? No, just the 5. So I write it here. 5. However, check this out. I'm not done. Everybody look up, please. Do we have any variables in common over here and over here? Do we have 1x? Do we have 1x? Yes, here and here. Okay, I'll write it in here. X. Do we have another x? Yes. Do we have another x? Yes. All right. So let's see. What was left over here? Just the 5. Do we have any variables left over that we did not use? No. What's left over on this side of numbers? 2 and 3. So I write 2 times 3. How about, do we have any variables left over? What are they? X and X. Are we there so far? All right. So with that said, our GCF, look at our GCF. We're looking at this intersecting region. What is 2 times 2? Times 3? 12. And what is x times x times x? X cubed. Are we there so far? All right. Now check this out. Our LCM, x to the 5th. Our LCM, which is easier to multiply, the 5 times this or this times that? So what is 5 times 72x to the 5th? So let's see. So what is 5 times 70? 350. What is 5 times 2? So what is 350 plus 10? So the LCM is 360. Do we have any other variables that we need to multiply? No, so we just write x to the 5th. So this is the LCM, and this is the GCF. So far so good? Okay, let's do another one. Okay. All right, get another paper going. Here we go. Copy this one. Negative 90a to the 5th and negative 72a squared. See if you can do that one by yourself. Go. All right, here we go. So, first things first, you wrote your first 5 prime. You rewrote your numbers. You wrote one negative 90a to the 5th. And this one is negative 72a to the 2nd. Are we there? Okay. So, from there, let's see. Which number of these divides into 90? The 5 or the, I'm going to start with 3. 3. So that's 30 or negative 30. This is a prime. Again, what number divides in there? 3. 3, and this is negative 10. Circle that. What other number? 2 and negative 5. Are we there? Okay. Next, over here. This is 2, and that's 36. Negative. Circle the first prime. This one is 2, negative 18. This is 2, negative 9. And this is 3, negative 3. Is that correct? Okay. Some of you factored, who factored a negative 1 at the beginning? You could have done that also. Okay. Let me continue. What is my prime factors for a to the 5th? A times A times A times A times A. How about over here? A times A. Okay? So let's see. Here's my Venn diagram. Nice and straight. Okay, there it is. I'm going to go one step at a time. Do we have a 3 in common? Everybody, do we have a 3? Yes, which is right here. Okay, I write it. Do we have another 3? Yes, right here. But check this out. I'm going to change this into a positive and write right outside a -1. Is that okay? So this is 3. Okay, so this one has a -1 left over here. Just remember that. Okay. Next, do we have a 2 in common? Yes, the 2 and a 2, so times 2. Okay. And by the way, check this out. Can I factor out a negative from here from the 5? Make this into a positive, and then times what? -1. So now, do both of these have a negative in common? Yes, a -1 and a -1. So I write that in here. Okay. So, what's left over for this one in numbers by itself? The 5. How about for this one? The 2 times 2. Is that correct? All right, now let's go with the variables. How many variables do both of these have in common? 2 A's, this one and this one. So I write them in here, A and A. How many are left over out here? A, and A. How about over here? Any of them? No. So check this out. So my GCF is, what is 3 times 3? Times 2 times a -1, -18. And what is A times A? A squared. And that's my my GCF. I know they are. Now, LCM. All we have to do is multiply 5 times what? -72a to the 5th. So I'm going to write -72a to the 2nd, I'm sorry, times 5. So therefore, that is 10. We got 1, 35, that's 36, and it's a negative. So this is -360, 8 to the 2nd, and that's my LCM. Hands if the process is already sinking in. Yes? Okay. Oh, thank you. However, what did I forget to multiply here by? A to the 3rd, is that correct? This is A to the 3rd, so what is A to the 3rd times A squared? A to the 5th. Thank you, Felicia. All right, everybody got it? All right, so now, check this out. There's only one more example to go through, which is a word problem, but I want you to read into that in the book, okay? So for homework. Page what? 481, numbers 1 through 35. Oh, 43 odd, my bad. 1 through 43 odd. Hold on. Also, I'm going to give you your party back. I want that signed and brought back tomorrow with your homework. Yes. And then afterwards, you may leave and have a good one. Enjoy your homework. See you guys tomorrow.